Hi everyone, thank you for coming. We're just waiting for the last speakers to leave the room. So I've been told that I am in between you and happy hour, but that also means that you are in between me and happy hour. So I hope this is worth the next 45 minutes. So I'm going to talk to you about the AWS services that can enable you to embed AI and machine learning capability into your applications really easily. So we're going to look at some of the API-led services, and we're also going to look at some of the platform services that can take you to that next level of complexity where, you know, perhaps some of the standard pre-trained models aren't going to be what you need for your use case. And I want to try and encourage you to kind of dip your toe into actually training some of your own models and taking that to the next level in. First of all, I want to just sort of have a think about where Amazon has come from, and obviously where Amazon Web Services gets some of the capabilities around machine learning from. We started over 20 years ago building recommendation engines into the online bookstore at a time when that was seen as something particularly strange and peculiar to do. We still now have teams of data scientists looking at how we manage our logistics centers, how the robots manage placement of products in those data centers. And you can look online at the robots and how they move the shelves around, how the products are scattered around the data centers to optimize how those fulfillment centers rather operate. And they're vast buildings. So how do we optimize that picking and selection of goods in those warehouses? Many of you will have heard of our drone sort of work that we're doing. So we have a big engineering capability up in Cambridge in the UK that's really focused on how do we build that drone capability. Amazon Prime Air is what that's called. I'm hoping everybody in here has heard of Alexa. Hoping many of you have an Echo device in your home, whether that's for timing how long your kids are allowed to play on their computer games for, or playing music, or whatever it is you use your Echo device for. That ability to interact with Alexa as a human is artificial intelligence at its core. It's imitating a human being, and we talk about Alexa as if she was real. And finally, Amazon Go is trying to reimagine, it has reimagined how the physical shopping experience is. So there's one store in Seattle that's opened last year, I believe. It has no checkout, so you can walk into that shop and put stuff in your pockets and then walk out again. And as you leave, you get a bill sent through to your phone. It's using video processing. And if you look up in the ceiling of the shop, there are many, many black boxes that are recording everything that happens. They're tracking people as they go around the store. It knows as you move behind another person and is able to keep track of everything you do so that it can accurately bill you as you walk out of that shop. All of these things are not possible without deep learning and machine learning baked into the services that they provide. So at AWS, our mission around all of this is to make some of that capability available to you as services. And so we're going to talk through some of those today. Particularly, we look at voice and speech services and video services, both of which the data from both of those streams is very hard, almost impossible to process without deep learning capability. So making that available as an API allows you to then orchestrate those capabilities together into new interactions, new ways of processing the data that's key for your business or personalizing content for your customers. But we also have platform services that make the job of the data scientist simpler. So we've pre-packaged and we manage the platform that delivers TensorFlow and MXNet and Caffe and all of these frameworks that as a data scientist you might need. But it makes access to that capability easier as well. So if you're not a data scientist, if you aspire to be a fake data scientist like me, or you're just starting out on this journey of around this technology, then a lot of that heavy lifting has been taken away. Managing the machines that train your models, deploying endpoints that you can then use within your applications has simplified and made much easier as part of a platform. So we'll break this down into a four-layered stack. We're going to focus on the top two layers, the application services. These are the pre-trained models with machine learning capabilities baked into an API. And then the platform services that give you that next layer of complexity when you need something a bit more bespoke. We also have pre-built machines for a broad range of frameworks and interfaces. So those are for the sort of, if you want to start building your own and you have that data science capability within your organization. And of course, then you need some hardware to run it on. So our infrastructure then kicks into place, and our GPU instances are what you really would want to focus on there. So let's look at what this stack is. So in the application services, we're going to focus on both video and text-based services for this. So Rekognition is our video processing capability. Transcribe, translate, poly, and comprehend give you various different language-based processing, and Lex is really the brains behind Alexa. So we're going to go through these now. So Rekognition gives you the ability to extract thousands of labels, thousands of individual characteristics from visual content. So that might be object and scene. So the image on the left there has got a cyclist, it's got a person, but it also knows that there's a path and a mountain and a bicycle. So it's picking out all of those things from that image. Similarly, with facial analysis, it's going to extract that metadata. But then on the other side of that picture, we've got both celebrity recognition, the ability to pick out famous faces from content, and we'll look at a really exciting, if you're into the royal wedding, a very exciting use case of this service in a moment. But image moderation, if you're running a social network and want to be able to moderate for inappropriate content, then you can use the service to identify images that you may want to censor on that just by a simple API call of that image. So here's an example of a very lovely house with a lovely pool. You can see some of the labels that the Rekognition service is able to detect from that image. And you might be having like a holiday site, or you want to be running your holiday snaps through the picture, and you want to group them by the ones with the nice pictures of the pool. All sorts of use cases around that, and there are thousands of labels that the service can identify. On this image, it's picking out a number of different aspects around this person's face. Sentiment is something that a lot of customers are wanting to extract from images. Is a customer happy? Has a customer left sad? We have another very a colleague of mine is building out solutions around security, around railway stations, and how can the operators of that platform know if there are people that seem to be drunk on the platform that might be at risk of falling into the tracks. So there's all sorts of different aspects around the ability to pick out characteristics. Another thing on this picture is image quality. So you might want to be able to automate just the filtering of images that you have in a data store that are of better quality, so that you can filter out some of the ones that just don't have good image, rather than having to do that manually. And we've always had you may have heard of Mechanical Turk, which is a service that gives farms out sort of tasks to people, but these are very labor-intensive tasks, and typically it's not cost-effective to do them, but the ability to do this in an automated way through vast quantities of data really makes that viable. Now this is Rekognition video. So you'll see as it's watched that video move across, it's been able to track each individual character as an individual, and it will follow that person across the image. It might be a dog or a car or any other kind of aspect of that image. Now then, the service is able to tie back into a database that says, have I seen this face before? Is this face in my collection of known faces? And then match against the images that are passing through. So obviously really, really good for security cameras, maybe knowing your customer. If you're running a hotel, it'd be nice to know if your customer has stayed with you before. There's all sorts of interesting use cases you could build out with that. So here's the big announcement that Sky News made this week about the royal wedding. They're going to embed Rekognition into some capability on their streaming of the royal wedding, so that they can track celebrities as they come into the wedding, into the church, and also then interact with stuff they already know about those celebrities. So that if, like me, you see these pictures and you think, who is that? Now you don't need to anymore, because the people from Towie are now described for you on the website. So let's change a little bit now. We'll talk about some of the speech and text capabilities. And there's a few of these, and we're going to just look at all of them and then think about ways of using them in the end. So Transcribe gives you the ability to convert speech into text. And speech is typically quite hard to process. So if you can convert it into text, it then gives you a number of things. First of all, it's much easier then to store it. It's much more condensed data format, so it's cheaper and easier to store it. But as you can see, then we can use other services against that text to get meaning and process that text. What's really nice about Transcribe is it's not just going to give you a stream of text, but it's actually going to punctuate and format that text for you, so it becomes human readable as well. It puts timestamps on that text, so you can track a vocal text with timestamps so that you know when certain things have occurred within that text. It supports multiple speakers, so if you've got conversations, customers phoning you and you want to record those calls, you can actually identify multiple speakers within that conversation and have them identified within that transcription. And this is something that would be really hard to do with all of your call data. And it wouldn't be cost effective to transcribe all of your call data with traditional mechanisms. But with this kind of service, it becomes quite easy to do. Now then you can think about the next service, which is Comprehend, and that gives you the ability to derive meaning and context from text. So let's think about this. We've taken our call data, we've passed that into a text file from Transcribe, and now we've run that text through Comprehend. And now we can start to see what are our customers asking for, what content is in those conversations, how many customers are happy or sad in that interaction. What's everyone asking for? Is there some metadata that we can pull that can help us understand maybe new services we want to offer, or new fixes that we want to put into our product, or just tracking through histories? There's an example on the page. News articles. What's going on in the news? What's coming through on Twitter? How do we get insight into that content? Now, Comprehend has both an API and this is the browser in the console. And it shows you how it scans through text and then gives you sets of entities and categorizes those entities, as well as giving you sort of a confidence level around what that particular entity is about. So you get a JSON file back that allows you to then process that content and do something useful with it. So if we think about, as we were talking about just now, how would that look in an architecture? How would you chain these services together? We've got some calls coming into a call center. I've used Amazon Connect because I work for AWS, but you've got a call center recording that you've then dropped into S3. Once that data is sitting in S3, we can transcribe that into text. And we've now got a textual version of that conversation. We've passed that through Comprehend. We've pulled out the various entities and key phrases, the sentiment that was within that conversation. And then we can do all sorts with that. We can automate the opening of a ticket based on a customer phoning up and saying, my system's broken, I need an engineer. We can automate that ticket opening via Lambda or a call back to that customer. We might want to process that data of all of our calls in a more complex way using machine learning capabilities we're going to talk about in a minute. Or maybe we just want to build a dashboard so that we can see the kind of things customers are talking about, or the number of calls where it looks like the customer was unhappy when they called us. We can measure whether they seemed happy at the end and track that. There's all sorts of things you could build as part of this, which you would not be able to do if you just had people answering the phone and taking a few notes down. So another language service that's available is Amazon Translate. Now this gives two kinds of interaction. We've got real-time and offline translation. So real-time translation is, as it says, it's immediate. So that would be really useful for if you've got like an online service or support team that want to have be able to interact with people who aren't perhaps entering requests in their own language. You can immediately translate those back and forward and some kind of chatbot that gives you an immediate translation. But you also might want to just translate your website capability into another language. You need to open up part of your website in South America or in Spain or somewhere where there's a language that you don't have the translation capabilities. So you can very easily just parse your text and it will give you the grammatical translation of what that text should be. Now, Polly is a service that will translate text into speech. So we've gone from speech into text with Transcribe, and Polly converts that text back into speech. Now, what's really nice about Polly is it's not just an automated voice, but it is giving the intonation and the cadence of natural speech. So whilst it doesn't sound like a human, it doesn't also sound like a very robotized sort of cadence of speech. It puts in pauses. You can set up so she pauses for breath, and you can hear her breath, and it starts to sound very, very human-like. We use it with, I mentioned earlier, Amazon Connect, which is our call center capability, and you can actually put Polly as the agent on a call center so that you can filter out sort of first-line calls via Polly without them ever actually having to interact with a person. There's 50 different voices across 24 different languages, so there's a vast range of both accents and languages that you can use, and it's incredibly low latency, so it's very quick response, so there's not a sort of long pause, so it seems very natural, and you can have a conversation with Polly. You can also record and pre-record conversations, so you can have an interaction that you load and then reuse that interaction over and over again. And it's also possible to embed Polly within a WordPress site. So there's now a kind of close tie with that. If you want to have some kind of voice interaction on your site, then that's also possible now. Now, one of the things you can do is to play around with some of the aspects. So whilst it will put in quite natural sounding cadence into a conversation, there might be extremes that you want to do. So in this example here, we've edited the text so that it speeds it up and makes it louder. You can make it slower. And there's a number of different capabilities that you can do with this, with a markup onto the text. So I'm going to play you this. And hope you can hear it.
I want 550, 550 bit on 550, I add 550, 550, 550 for 2 the owner, big black button, big black bear, big black button, big black bear. Do we get 600? A big black button, big black bear, we got 600 for that whole hertz sold for 600.
So you can have your own auctioneer on your own site now. But yeah, you can have a lot of fun with this, but you can also build out some quite interesting capabilities with that service. Now, the RNIB are using Poly to record books for their members. And they've 2 million people with sight loss in the UK. RNIB had the largest library of audiobooks in the UK. And they're using Poly as a way to just record more books. So all books now are digitized, so the ability to process those as audiobooks is really nice for the RNIB, and it's given them the ability to sort of reach more people with that service, but in a very natural sounding way. So that's a really nice use case for Poly. So let's look at Lex. So I said at the beginning, Lex is the conversational aspect of Alexa, so it's deliberately named as that reduced word. So this concept of having a conversation with a machine introduces a lot of design challenges around how do you interact in a conversational way, and how do you design that user interface so that it's both natural but also is able to adapt to the varying different ways that we say the same thing, and that's inevitable. So both building chatbots and those kind of online assistants, support bots, but then also productivity bots. And if you were at the last session, we heard the Babylon Health have got their healthcare bot that enables you to talk to Alexa in a way that gives you a medical diagnosis. So they've built some intelligence in the back end, but that conversational interface is basically using Alexa technology. How do you interact with smart devices and wearables, and how does that then open up new possibilities for ways of both personalizing but also interacting with your customers? How would it be if every time you walked around this site, you were able to talk to a device that understood what you'd been to see already, what you might want to go and see next? There's all sorts of use cases that you could build to make that interaction more natural, more conversational, and very personal based on each individual user, rather than just a poster that people would read. Now, Freshdesk is a customer that have built an automated bot for support help desk, and it all runs using Lex and an automated AI system. So they've got the natural language understanding of the bot that takes the original request in from the customer. It potentially integrates with some back-end processes and some flows, and the support agents can also interact with the system. So they're kind of both sides have the ability to talk to the system and manage support cases as they go through that business process flow that they're offering with their ticketing system. So we've talked about some of those AI services, and for many use cases, you can really easily just integrate those services into your applications, and you can build out quite capable, quite personalized machine learning skills. No need to train models or interact with complex deep learning neural networks. The next step on is actually when those models don't actually answer the use case, when you've got a slightly more bespoke use case and you want to then start to look at whether you can train your own models and build out something a little bit more complex than the services that we provide. So we're going to look at a couple of platform services for this. We're going to look at Amazon Machine Learning to start with, which is probably the place to start. And there is a machine learning process that the most advanced data scientists will go through, and this is the process that you need to sort of start with. The first thing is collecting your data. It all starts with the data. Data comes in many different formats and qualities of data, and so there's a process around understanding what the structure of the data is and potentially parsing the data for missing fields, untidy data, understanding where there is unstructured data within your data and where it's structured, and kind of cleaning and preparing that training data for running through the training algorithms. Once you've done that sort of tidying job on that data, you then need to pass it through your machine learning algorithms. And you pass that data through, and the algorithm will then process each row or each set of data through its model to build a trained model at the end of it that you can use. You then need to set up and manage your environments for training. So whether that's the hardware or the machines that you're going to use for training the model, and typically the training of a model requires far more data far more resource than the inferring post-training. So being able to use hardware that you haven't had to buy is a perfect use case for cloud, right? So being able to train those models on high-end GPU instances gives you the ability to train large amounts of data in a relatively short time. And then there's an iterative process. So you might train your model, you get an answer at the end of it, and you think, well, actually, I'm not quite sure this is quite right, and you may need to iterate on some of the parameters, and we'll talk a little bit about what that might mean. But you don't necessarily, and probably you don't usually, get the right answer, and most of the work done with machine learning is in iterating and fine-tuning the parameters around that model that you're going to then use going forward. So let's have a look at Amazon Machine Learning. So this is a managed machine learning service. It gives you the ability to train models and then use that trained model to then learn new things about new data. So there are a couple of different types of classification and model that are possible in machine learning. So one is a classification model where it's trying to group the data into sets. There might be binary classification where you have just two sets, whether that's yes and no, or true and false, or dog and cat, but we've got two different groups and we just want to split the data into two groups. And that two group might be, is a customer likely to leave or stay? That is also a binary classification problem. Multi-class classification is where you've got a number of groups. So you want to split some data into 20 different groups, all of which are unique within your data set. In this example on the slide, is this a book, a movie, or a piece of clothing? But you can think of all sorts of use cases, I'm sure. A regression model is where you're looking for trends. You're looking for relationships in the data and patterns in the data, usually over time. And how much is my house going to be worth in a year's time? Or is it still going to be sunny tomorrow? What's the temperature in London going to be like? I always think weather in the UK is probably quite a tricky one to predict. But those models are where you're plotting a line over time and trying to predict an outcome. So let's just break that down into a few steps and just try and visualize what that is. So we're going to start with some data. I hope you can see that data. So I've condensed it down. There were quite a lot of columns that didn't all fit on my slide. So we start with some data, probably sitting in S3, but it might be sitting in Redshift. So you point it at your data source. And if you look at that spreadsheet, there's a number of columns of data. And then the last column on the right is a binary output. And this particular data set is whether or not a customer responded to a mail shot that was sent to them. So we're tracking data and saying, did this customer respond to the mail shot, yes or no? So we've got a binary answer to a vast set of data on the left there. The system, once it's loaded the data source into the system, it will then parse the data and infer a schema, and it gives you the ability to correct it if it's got that wrong. But it's just a standard kind of parsing of the different data types and identifying if it's numbers, is it a category, or is it a binary number. Once you've done that, you need to tell the system what is the column of data that's giving me the answers that I'm training against. So in this set of data, I've got that binary column on the right that says this customer responded, this customer didn't. So you tell the system what were the outcomes on the training set of data. And it's worth remembering that you always have to have a training set of data with this system. So you're always going to pass it information where you know the answers, the historical data. And then we have the new data. So then we have the new customers, and we want to decide whether or not we're going to send these customers this mail shot or not, based on the likelihood that they're going to respond positively to it. So this set of data doesn't have that binary column of yes, that's the answer that you're looking for in that set of data. And then you need to pass that new data through the system. So you've trained your model with the training data, and then you have a trained model. You pass the trained model the new source data, and you're asking it to predict an outcome based on everything it's seen in the past. Now, there's then a little bit of tuning that you might want to do to this model. Now, if you look in the box there, I've got prediction. And if you look at predicted scores, it's 0.03 and the rest. So what that means is for that particular piece of data, it's a 3% chance that that customer is going to respond positively. That's the prediction it's making. And we've set a threshold on this data that then decides whether, for a 3% chance, do I say this is a yes or a no? And so it's all about the likelihood, the confidence level that this customer is going to respond in a certain way. And you set that bar depending on what the use case is. Some use cases you need to be really accurate, so you'd probably want to set your threshold quite high so that you're very confident of the outcome based on the historical data. For other use cases, you might be able to take more flexible view. You might say, well, actually, we'd rather send out too many mail shots. The problems of sending them out to too many people is okay. So we're okay to lower that threshold. That means we send out that mail shot. And each use case is different, and you would want to think that through for yourselves. So that's Amazon Machine Learning Service. New service that was launched at the end of last year was Amazon SageMaker. And SageMaker really takes the use cases that you might want to resolve to the next level of complexity. So there are going to be use cases where you actually need to have much greater and much more control into what the algorithms that you have available to you and how you tune the parameters. And so SageMaker gives you quite a rich environment for doing this in. It gives you Jupyter notebooks that it's going to manage and maintain for you. And Jupyter notebooks are a way to actually programmatically code both the loading of that data that we saw before in the last thing. So you programmatically can load the data. You pass that data into an algorithm that you choose that the platform is managing. And then you're able to deploy the trained model as a Docker container that's then run and managed by the platform. It's giving you the ability to both take advantage of algorithms and frameworks such as TensorFlow and MXNet that we're managing for you, but also to iterate on those notebooks so that you can store those notebooks in Git and share those around your team, and you can iterate through various different versions of your model and load and deploy them within the platform. The other thing it does is it allows you to both bring your own trained models that you run on SageMaker, so you run on our hosted platform, but you've trained those models on-premise, and vice versa. So you can train a model on the platform and then maybe run it in production on-premise. And we're using Docker containers to make that possible, so you can just move those containers back and forth. So that's a really, that's like the next step of the next evolution in your path to becoming expert fake data scientists. So if you want to learn a bit more about SageMaker, there's a couple of sessions tomorrow, and I don't know how many of you are coming tomorrow, but I hope you all are coming tomorrow. So there's a couple of sessions middle of the day around using SageMaker, both just someone's going to, I think it's Julian's going to do an actual coding demo so you can actually see the evolution of a system using SageMaker live. We've also got a use case around fraud detection using SageMaker, so that's really kind of common ask for machine learning is how can we detect fraud real time? So that's going to show you how to build that kind of solution using SageMaker. But then in the afternoon, there's a couple more sessions around using the AI and ML services. So those are, that's going to be your fastest route to success with some of these capabilities. So a couple I've pulled out there. One is around the language AI and ML services that we talked about earlier. And then using IoT and machine learning for energy companies. So, all of that data from sensors and IoT devices at the edge, what can you do with that data and how to augment and use that data to just change how our power and utility companies are kind of operating. That's all I've got. I thank you very much. I hope that I've kind of given you, it's been a bit of a whistle-stop tour through a number of services. What I want to just hope you take away is that actually embedding some of this capability in your applications is very, very straightforward and very, very available to you today. And I hope that's sort of helped just follow that process through. Thank you for coming. Happy hour.